Hey guys, my name is Ethan, this is Carberra, and welcome to the series where I teach you how to build a game in Python. Today we are covering perhaps the most important topic of them all, creating and controlling the snake. Now obviously the snake is our main character, we have an apple in there already but we don't have anything to eat it, so that's what our snake is obviously going to be. This is going to be quite a long and difficult video. There's a lot to talk about, and we're also taking advantage of a number of things that Python has inbuilt per se, that are a little bit lesser known. So we're going to be using dex from the collections library and enums from the enums library. So on top of all the complicated stuff we've done so far, we're going to be adding even more to the mix. So this is probably going to be the most difficult video so far. Whether it's the most difficult video in the series, I don't know. But before we get into that, I want to talk about something that could potentially help out if you get stuck with this or anything else. And that'll be this video's sponsor, Areize. Areize is a tutoring platform designed to make finding and booking tutors quick and easy. With just a few clicks, you can book singular or weekly sessions with a tutor that suits you, from subjects such as math, science, coding, and more. In fact, I'm even on there, and you can use the code CARB20 to get 20% off your first session with me. So if you ever need that little bit of extra help with this series content, or you need some extra help with a personal project or whatever, you can click my Areize link in the description below and use the code CARB20 to book a class with me. So this is probably going to be the longest and most complicated video yet. However, thankfully, most of it is encased within a single file. There's only some very slight modifications we need to do to the scene. But actually creating the snake and getting its behaviors right is somewhat complicated. So I'll try and go through it fairly slowly. We'll see how far we get. The thing I said, was it episode 5 or something? About not needing to create a new file. I decided that it would be better if we actually do create a special file for the snake. So what we're going to do is we're going to do a right click and we're going to do snake.py. And then this is where we're going to do most of our stuff. In the init, I'm just checking the order. Okay, so in the init we need to do from.snake import snake. If you do it above, I think if you do it above the scenes it starts complaining. So just make sure you're aware of that. But yeah, so we're going to do all our imports now. So from collections import deck. Now for those of you that don't know what a deck is, it is a special type of list. It's essentially a double-ended list, per se, in the way that it can do operations on the left side and the right side equally as fast as each other, which is not a property of standard lists. So a deck makes it faster, which is why we're using them. And then we do from enum import enum, because we're going to be using enums in this as well. And then we do the standard import Pygame as PG, and then import snake as always. So we're going to create our direction enum first. So an enum is sort of like a series of states. I guess that's the only way I've used them in the past. You don't have to make them an enum, but making them an enum is what people normally do, and it also gives you a few extra features. It might be slightly faster as well. I really don't know. Most stuff that you import in, like the collections library, for example, a lot of the stuff in there is standard Python but quicker. So I don't know, enums might be faster this as well. I don't know. We're going to set up equals 0. We're going to set down equals 1. We're going to set left equals 2, and we're going to set right equals 3. Now you can do or you can import an auto function from the enum, and some people may be asking, why aren't you doing that? Well, it's because we're using these particular values very specifically to help with something. So you need it to be 0, 1, 2, and 3, and you do need them to be in this order, if at all possible, so keep that in mind. We're then going to create a direction mapping dictionary, which is a little bit ugly, but it does... It's essentially less ugly than the other solution, so we're working with it. So for each key, so key up, key down, key left, key right, if you want to use WASD, you can use those instead. We're going to set a tuple, which is first a mapping of the direction that they correlate to. So if you press up, you would expect the snake to go up. But we're also going to put in the opposite here. It's easy to just explicitly state it and try and work it out dynamically, so and that'll make probably more sense once we actually see what I'm using these for. So if you're not following quite yet, then it's fine. It should make sense later down the road. But essentially what you want to do is you want to have, you know, the key and then the direction they correlate to and the opposite direction to the direction that they correlate to. And this basically just makes the movement of the snake easy to handle. And what we're doing here is we are ridding the need for a lot of if statements, a lot of very ugly if statements. And we're essentially cleaning up a bit of the code massively further below. Now that we've got that, we can actually finally create our snake. It's not going to import from anything. And then we have our slots, and there's a lot of slots as well. So part, oopsie daisies, body, max len. Decks have a max length, but it's not an adjustable max length. So we actually need to create our own max len implementation. Oh god, see, game dev is hard, man. I did tell you. Movement delay, and then these are sort of more just flags. Really, direction changed especially is a flag. So we do def in itself, and then we take the parts. Now this is actually a surface, but the snake itself is going to be a chain of sprites. So we need to get the width of the sprite, which again in our case is 16, but it might be different for you if you've done custom sprites. So we're just doing it slightly differently here. Height, and then x equals round, and then we need double brackets. Snake dot window width, because we're just going to spawn the snake in the center of the screen. I don't see a reason not to, really. So just thought I've used a double slash here, but not elsewhere. Let's see if we can get away with that. We should be able to, because it's rounding it, so it's not going to have any issues with there. And then round, and then snake, there we go, dot window height divided by 2 divided by h times h. And again, that this whole dividing by and then timesing by locks it to a grid of 16. So now we have the body, which is a deck. And to create a deck object, you just pass a list to it. So you sort of create a list in itself. And decks can be index sliced in the same way. They essentially just have extra features that make them faster to do stuff in specific ways. So we do snake.sprite, self.parts, x and then y, and then close that bracket, and then snake.sprite, self.parts, I always do path, I have no idea why, x minus w, and then y. So we're creating a snake of length 2 with, you know, one bit being directly behind the other. It just makes it easy to work with. Self.maxLen equals 2, which it currently is. Self.direction equals direction.right. Self.speed equals 10. Self.movement delay equals 0, and that's going to be a float, so you might as well indicate it as such. And direction changed equals false. So next thing we need is a property to indicate the movement interval. So obviously it's going to like go boop, 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 boop across the screen in you know, jumps of 16. But we want to control the speed in which it actually jumps. So this is where our movement interval comes in. And this is going to be a return 1 self.speed. So self.speed is not a constant. It is going to be updated throughout the game. So having this just makes it easier. So we can do change direction script now. So self.key, and we are going to pass the key in because, you know, we want the direction. So if not self.direction change, so if the direction has already been adjusted this frame, then don't do it again. Essentially, it just stops things from breaking. Really, it's the main reason we're doing this. We're doing so for key, and then direction it's, you know, relative to, and then the opposite direction is relative to. And yes, we do need to have a tuple because we're unpacking the tuple within the for loop. In direction, this might be the first master video. We'll see. I don't know. I'm not sure it quite gets there. It's definitely well into expert though. If key double equals k, if self.direction does not equal o. So what we're doing here is, you know, if the key we've pressed is the key we've come across, if the direction, if the current direction does not equal the opposite direction of where we want to go, then we update the movement direction to equal the one that is relative to the key. If that makes sense. I realized that was a horrible explanation. Essentially what we're doing is, so if the snake is traveling right, we are preventing us from just being able to say, oh, you're going left now, and going through itself. You would need to go up and then left. So this is basically saying, if we're traveling in a specific way, don't just allow us to do the opposite and go the opposite way. And you'll see what I mean when we actually get into the game. Self.direction changed equals true. And then once we've done that, we need to break. We don't want to waste the extra time going through the rest of the loop if we don't have to. So now, and also this is where we've, saved on a lot of if statements, because this is, this would be if statements otherwise. If key equals up, if key equals down, if key equals left, if key equals right. If you've got WASD as well, it'd be if key. It's just a mess. So it's easy to do a for loop. Now we need to shift. I've sworn several times trying to type that word. This always happens. Oh, it always happens. Self.body.append left. So this is a thing specific to Dex. Snec.sprite self.parts X and Y. And at this point I'm going to explain why we don't use a list, because we are going to have to append it one way or another. So appending to the right, Dex and lists are approximately equal. So you're thinking, well, why don't we just append it to the right? Because if we append it to the right, we're going to have to pop it from the left, which is one, I'm pretty sure something you can't even do in a list. So I think you can remove the 0th element, but actually popping the left element is faster in a deck than popping from the left in a list, in the same way that appending to the left is easier than inserting it. It just, if you're doing dual-ended operations on lists, you need a deck. Otherwise, you can use a list. That's the basic rundown, really. So if why have I done that in brackets? If the len of self.body is greater than the len of self.maxlen, then we need to, get rid of one of them. So we're not really moving the snake as such, as much as we're just kind of placing a new one where it should be, and then removing the old one. It's sort of like if a snake in real life weren't to slither along the ground, but instead move by constantly growing a new head and then deleting the tail bit. That's essentially what we're doing here, but it's the easiest way to do it, rather than just move everything. If you want to extend our snake, then we need to do, this might not be entirely complete. There was a lot of extra functionality in the plan originally, but I realized it wasn't being used. So I might need to come back to that and see. But for now, we're just going to put self.maxlen plus equals 1. To be fair, if there's no extra functionality, I'm probably going to remove this function entirely and just have it done kind of where we actually extend the snake, because, function calls are slow. So this will probably change one way or another, but, I ran out of time to kind of, look that up, because I've got to plan the next episode, which I haven't done yet. So we're just going to leave it like that for now. The functionality is there. We can work with it. So we're going to have a self, and then we're going to have the delta for the move, because we actually do need the delta. So if self.movement delay is less than the self.movement interval, so if we're not scheduled to move yet, then we need to, kind of up the movement delay, by the delta, and then just, abort everything else. We don't need to do anything else after that. We just need to kind of increment the movement delay, so we can check the next time, if the movement delay is greater or equal to the movement interval, then we're scheduled to move, then we can do the rest of our stuff. So then we get the actual head of the snake, which is always going to be self.body 0. And then we have this movement thing, which I'm just going to copy paste, because I don't really want to copy this out, because this video is going to be long enough as it is. But this is essentially a matrix of our movement, or rather the new coordinates. So basically, this is why we had the self-direction as specific values up here, because we use the value of the enum to determine which set of coordinates we actually move to. So if we're moving, I think up is first. Yeah, so if we're moving up, then we need to keep the x coordinate the same, but we need to subtract the h. We need to subtract the height from the y, because of course 0 is at the top on computers, because computers don't follow the regular laws of physics or color physics or anything like that, and it's very confusing. But we need to subtract the height from the y, so we essentially move up one. This one down, need to add it, and then the same with the width, and then we just select one as it goes along. You can't have a constant for that, because obviously it's always going to be different. After we selected where we're going, we can then shift to the coordinates specified in our movement variable. We can then reset the movement delay, because we've moved, we now need to reset it, and we need to set the flag to say the direction change is no longer true. So yeah, that's all we need to do in the actual snake part. We now need to go into the scenes, and we need to do stuff in here before we can even test it. So we're going to get rid of this apple teleporting malarkey. We don't need it anymore. Well, we're also going to get rid of this as well. I'm just going to leave that empty, and it will cause errors, but whatever. We're going to get rid of this, and we're instead just going to place it with self.snec.move. I've been talking a lot today. Self.snec.move by the delta, and then in here we do self.snec.change direction e.key. So of course, if the key isn't a movement key, it just won't move the snake at all. And then we actually need to draw the snake, so we're not going to redraw the background for now, because I'm going to change it to make it a bit more obvious. So for part in self.snec.body, self.window.blit part. So we need to draw each individual part separately. But now, if we run this, there's all my Git stuff again. It should get an error. Fantastic. Main scene is now attribute snec, because I haven't initialized it ever. No, I haven't. I'm a good programmer. Self.snec equals snec.snec, and then we need to pass in an image to use as the part. So you can pass in anything here. You can pass an entire background if you want, and it will be awful. But we're just going to use our 16 by 16 purple, because we're on brand. Snec part.png, and then we're going to do .convert alpha, and I guess apparently I haven't put any coordinates in the plan, so apparently we don't need them. Oh yeah, we don't, do we? Because it automatically selects them. Oh, we need to put snec in the slots. That's something we need to do. And there we go, we have our snec moving, so you can see, oh, it's event.key. Going by my plan again. I really need to unify variable names and stuff. There we go. So now I'm going left, now I'm hitting down, we're going down, now I'm hitting right, we're going right. If I hit left, don't do anything. If I go up and then down, don't do anything. Left, right, don't do anything. Down, up, doesn't do anything. The only thing it does do is it goes off the screen, and then we can still control it, so we can still bring it back. Now, we can't eat the apple. It doesn't, we can't collide with ourselves, not only because we're not long enough, but there's nothing there. We can't really do a lot. All we can do is just move. And this is what we're going to be changing in the next video, because we're going to be talking about collision. So we're going to be talking about how to collide with the apple, how to collide with the border. We're going to be doing the screen wrapping, I think. That might be split into 2 videos. I don't know. I haven't actually planned that far yet. But over the next few videos at the very least, we're going to be talking about, collecting the apple. We're going to be talking about wrapping around at the boundary of the screen. We're going to be talking about colliding with self to cause game over. We're also going to be doing a pause screen and a game over screen, and it's going to be great. It's going to be great. But who knows? But yeah, that's enough for today. I think we did a lot. Of course, if you have any questions, which you probably will, this was a hard one, I will say. So if you do have any questions, don't be scared to leave any in the comments below. Or you can join the Discord server using the link in the description. I would like to thank my amazing patrons on screen now. £1 a month you can be on this screen too. And I will see you next time where we talk about the aforementioned collision stuff. So I will see you for that.